Welcome in the second section of our Building Big Data Analytics stack. And in this section we'll be looking at the Apache Spark. So we'll be writing Spark jobs, we'll understand the Apache Spark technology. So we will be looking at Yarn and we will be looking at RDD. So we'll see how this is distributed, how that computing works, and we'll be partitioning our data. And in this video we'll be writing Spark jobs. So we'll be looking at the Spark architecture, at the RDD, partitioning in Spark, and transformations and actions. So let's look at the Spark architecture. So in Spark we have multiple components and one Spark driver. So we have a Spark driver and multiple Spark workers. We can scale that number of workers, so if we have a processing that needs to be executed faster or we have a lot of data to process, we can increase number of Spark workers, but Spark driver should be only one. And under every Spark worker, we need to have some kind of data storage. So in this example, this is a data node from HDFS. And in Spark, the main building block of every job is the RDD. So this is a resilient distributed dataset. So this is a distributed collection that is immutable and has a friendly collection API abstraction. Every worker is processing only part of that dataset. RDD is also fault tolerant. We will see how this is achieved in a moment. So let's look at the RDD in this example. So we have a list of 3 elements, A, B and C, and that list is submitted to Spark driver to perform some intensive computation. Then Spark driver is see that it has 3 workers available. So it will partition that data and send small part of that data to every of its worker. So element A will be sent to Spark worker first, element B to Spark worker second, and element C to Spark worker third. And each of those workers will execute some computing on those elements independently in parallel. Every RDD in Spark is immutable. So if we will create RDD, firstly by loading some data to our program and then we will filter results, it will create second RDD, and that second RDD will have a pointer to first RDD. And first RDD is a source RDD, so has no pointer yet. Then we want to do some mapping on that second RDD. That mapping operation will create a third RDD that is pointing to its parent, that is second RDD. And we can see that every transformation that we applied didn't change the source RDD, because every RDD is immutable. RDD is also fault tolerant. So let's go back to our situation when we want to process list of ABC and C was submitted to Spark worker third. And in the meantime, when that element was processed, something bad happened and Spark worker stopped to working because there was some kind of crash. And in the case of a crash, that worker will be restarted and they recompute C value again. Or if that worker is not able to restart, then that C value will be submitted to worker 1 or 2 and it will be recomputed. Let's look at the partitioning. So let's say that we have a dataset of elements from 1, 2, 3 up to 30. And that data needs to be partitioned somehow. In the previous example, we have a really simple dataset of 3 elements, so we partition it into 3 separate workers. In this example, we have only 3 workers available. So Spark will partition that data for us. So elements from 1 to 6, for example, will go to worker first, 7, 10 also first, then to second, then to third worker. But we can configure that partitioning scheme. So for example, we can have some hashing, because here we have range partitioning, because range of elements is sent to first worker, then another range to second, and so on. In Spark, basically we have 2 types of operations. So we have transformations and actions. transformations, for example map, flat map, filter, and so on. And as we remember, every transformation is creating new RDD that is immutable and is pointing to previous RDD, parent RDD. But if we are doing transformations on RDD, there is no computing executed, because all transformations are lazy. Only when we execute some kind of action, like for example take, count, or collect, that transformation will be executed and we will get result to our driver. Because if you want to take, for example, first element of computation, we need to trigger computation of those elements. There is no other way. So we have that example that we have an RDD that we are applying some filtering, mapping, some transformation, then we created another RDD, another, because we can see that there are 4 RDDs, and only when we trigger an action using lines with spark.count or first, that computation will be triggered, not earlier, only when action is triggered.